Hello everybody, welcome to the video. This one's going to be all about polygons, about what they are, and different characteristics about polygons. So basically, a polygon is a two-dimensional shape. So the simplest type of polygon would be a triangle. It has 1, 2, 3 sides. Here, this is a quadrilateral. It has 1, 2, 3, 4 sides. A pentagon has 5 sides, and so on and so forth. So make sure that you know these names for the different types of polygons. You should also know that a vertex is the point where the segments meet. So for example, in the heptagon, the vertices, which is the plural of vertex, would be right here. It's where those segments of the polygon meet. So that is what a vertex is. Okay, so you should also know that there's different words for different types of polygons. So a triangle is also called a trigon, so if you want to call it that, you can. A quadrilateral is also called a tetragon. There's also another word for heptagon and nonagon, so you can use those if you want to. But otherwise, this is what they're called. If you see a polygon that has more than 10 sides, we can just call that an n-gon. What that means is if a polygon has like 15 sides, that would be a 15-gon, and if it has like, 28 sides, that'd be a 28-gon, and so on and so forth. Okay, so here's some more definitions. When I say regular polygon, what that means is that all sides are of equal length. That's pretty much what that means, okay? So here you have a regular triangle, regular quadrilateral, and so on and so forth. An irregular polygon is a polygon that's not regular, so all the side lengths are actually different, as you can see in the pictures right over here. There's also this notion of concave versus convex polygons. So a concave polygon, it says here, has at least one internal angle greater than 180 degrees. So this angle right here that I'm about to draw, that angle is greater than 180 degrees. So this would be an example of a concave polygon. The way I like to think about it too for concave polygons is that it kind of caves in like this, like there's a space here inside the polygon. And that's different than a convex polygon where all the angles are no greater than 180. They're all less than 180. There's also this notion of what isn't a polygon, and that's pretty much if the side lengths are curved, or if it's not closed, or if it's not two-dimensional, something like that. So these are some definitions about polygons and characteristics you should be aware of. Okay, you should also be aware of the difference between an interior and an exterior angle. So here this is a pentagon drawn, 5-sided polygon, and you have 1, 2, 3, 4, 5 interior angles, these blue ones with a white center. These blue ones with an orange center is an exterior angle, and they're made if you just extend the side of a polygon by creating this angle. So here this is 1, 2, 3, 4, 5 exterior angles as well. So we know that the interior angles of a triangle always add up to 180 degrees. This is something that we proved a long time ago. But what about a quadrilateral? Well, you know that a square and a rectangle is a quadrilateral, and those shapes have 4 90-degree angles. So 4 times 90 is 360. But does that work for every quadrilateral, even a quadrilateral like this? And the answer is yes, because isn't a quadrilateral just 2 triangles? You can always just split it in half like that and create 1, 2 triangles. So what that means is that the interior angles of a quadrilateral always add up to 180 times 2, which is 360. The reason why you multiply it times 2 is because there's 2 triangles right here. And within each of those triangles, all the angles add up to 180. So A plus B plus C is 180, D plus E plus F is 180, and 180 plus 180 is 360. Now, what about the next shape, a pentagon? Can you tell what the interior angles of a pentagon is? Well, isn't a pentagon made up of 3 different triangles, right? So to find the interior angles of the pentagon for the sum, it's just going to be 3 times 180 because there's 1, 2, 3 triangles inside the pentagon. So 3 times 180 would be 540 degrees. So the angles in a pentagon add up to 540. So in general, how do I figure out the sum of the interior angles of any polygon? Basically what you have to do is use this formula right here. So you take the number of sides n, you subtract 2, because that's how many triangles there are inside the shape, and then you multiply it times 180. That's how to find the sum of the interior angles of a polygon. So for example, if you had an octagon, that's 8 sides, right? So 8 minus 2 is 6, and 6 times 180 is 1080. Now for the exterior angles, what you should know is that for each polygon, the sum of the exterior angles is always 360. So these are just three cases right here. Notice that the exterior angles, which I'll draw right here, this one, and this one, those add up to 360. These exterior angles add up to 360 for the quadrilateral, and these exterior angles also add up to 360, and you can see that for yourself. The reasoning there is that basically the exterior angles, if you kind of put them together, they kind of create a full rotation. And a full rotation, as you guys know, is 360 degrees. So basically what you guys have to know is that for each polygon, the sum of the exterior angles always adds up to 360 degrees. Okay, so let's put this to practice with an example. We're going to find the measure of one interior angle of this regular polygon. So how are we going to do that? Well, first of all, we have to determine what type of polygon this is, right? So how many sides does this thing have? 1, 2, 3, 4, 5, and 6. It has 6 sides, okay? And we need to figure out the sum of those interior angles. And when I say the interior angles, I'm talking about these 6 ones. So in order to do that, what we need to do is just apply the formula n minus 2 times 180. We know that n is equal to 6, so we can plug that in. We also know that 6 minus 2 is 4, and 4 times 180 is finally 720 degrees. So the sum of the interior angles is 720 degrees. Now, because this is a regular polygon, that means that all the angles inside the polygon are the same. So to find the measure of one interior angle, it's going to be 720 divided by the number of sides, which is 60, and that's going to be 120 degrees. So we'll go ahead and box that, and we can put that right here. Of course, I could have put it anywhere because they're all the same. But that's how to determine the measure of one interior angle of a regular polygon. Basically, what you do is you apply this formula, the n minus 2 times 180, and divide by the number of sides that it has. Okay, so for our last example here, we're going to find the measure of one exterior angle of a polygon. So once again, this is a 6-sided shape right here. And what you have to know is that, first of all, the exterior angles are these, right? It's just extending the line of each side of the polygon and measuring that angle. So what you guys have to know is that the sum of the exterior angles always adds up to 360 degrees. So in order to find the sum of one exterior angle, you take that 360, you divide it by 6, and in this case, you get 60 degrees. So in order to find the measure of one exterior angle of any polygon, you just take 360 and you divide by the number of sides.